Hey Trade class, let's look at this problem from section 4.1. So we have a angle measure here, 22 pi over 7, and we want to find a positive angle less than 2 pi that's coterminal with this angle. So what does that mean? So first of all, let's look at the angle measure 22 pi over 7. Let's think about on the unit circle the angle measures that we know. So hopefully you're getting used to the fact that that's our standard position, the positive x-axis on the unit circle. That's a radian measure of 0 pi radians. Up here this is pi over 2, pi, 3 pi over 2. Alright, and then this is also back to 2 pi. And then we just keep going around and around and around. We could just keep moving around this circle over and over and over again, and we would land at these same points. And what I mean by that is this angle right here, even though it is also it is pi over 2 radians, if I went all the way around to pi or 2 pi and then kept going until I got to pi over that positive y-axis again, that is 2 pi from here again all the way to here, but then I add to that pi over 2 radians and I get 5 pi over 2 radians. So what we mean by that is pi over 2 and 5 pi over 2 are coterminal. We end up at the exact same place. Okay, so what we're given here is 22 pi over 7. All right, 22 pi over 7, if you calculate it on a calculator, 22 pi over 7 is about 9.8. The radian measure is about 9.8. This fraction, 22 pi over 7, is about this. Well, what is that coterminal with? Well, if you look at what we have here, this is 0, 2 pi. 2 pi is 6.23. All right, 3 pi would be rotating again to here, going all the way around to 2 pi, and then rotating again would be 3 pi. If I type in 3 pi, I get 9.42. Alright, this is a little bit bigger than that, 9.8, 9.42. So this number is a little bit bigger than 3 pi. This is pi, but it's also 3 pi. So this 22 pi over 7 is beyond that, so we're like, over, let's say like right here, just to give a visual. Let's say that we're right here. So what we've done is we've gone all the way around. Right? I know this number is bigger than 2 pi, so we've gone all the way around, and then we've actually gone past 3 pi, and that's our angle measure, like that, all the way around, and then past pi. It is what this number is. So what are we being asked to do? We're being asked to find one that's between 0 and 2 pi. So that just means one swoop around like that. And coterminal means something in that green region there, that green circle, that stops at that same place where 22 pi over 7 stops at that black dot there that represents 22 pi over 7. So what are we being asked to do? The thing that you got to remember is if I move in this direction, angles are positive. If I move counterclockwise, angles are negative. So I am too big. I'm bigger than 2 pi. So what I need to do is move clockwise all the way around until I get back to here. And what that's going to do is that's going to remove this extra part right here that's gone past 2 pi, and it'll just leave me with this angle, right, which is the positive angle less than 2 pi, because I didn't go all the way around, so that's less than 2 pi. That's coterminal with the angle that we're getting. So all that to say that all we need to do here is subtract 2 pi. Okay, so 22 pi over 7 minus 2 pi, I need to get a common denominator. And by the way, I'm subtracting 2 pi because I'm moving in this direction, right? I'm starting here and I'm moving clockwise. And clockwise, that's this direction. That's a negative angle. So I'm subtracting 2 pi. 2 pi because that's a full revolution. So I'm going back one whole revolution, kind of unwinding to get within that 0 to 2 pi range. All right, I need a common denominator. So what is 2 pi equivalent to if the denominator is 7? That's equivalent to 14 pi over 7. All right, common denominator, I keep the common denominator. I subtract numerators. 22 pi minus 14 pi is 8 pi. So there's my answer. Okay, my answer is 8 pi over 7. All right, now, how can I do this with technology? How can technology help me do this problem without having to get common denominators? People, some people just don't like fractions. And you have to get common denominators and stuff to do this. So here's the thing that you could also do. Mathematically, if I am subtracting 2 pi from 22 pi over 7, I get this number. What I'm going to do is I'm going to ignore the pi. It's basically like I'm factoring out pi. Let me put it back in here just so you can see. If I copy this and paste this and take this pi away and then wrap this thing in a parentheses and then stick the pi back on after the parentheses, I factored the pi out. It's still equivalent. These are equivalent. So it becomes, if you can figure out what this is and just stick the pi back on, then you've got the equivalent answer. So it's basically, I'm going to remove the pi, work with this problem right here, and then I will get my answer, simplify it basically. Okay, so here's what we're going to do. 22 sevenths minus 2 is this decimal. I'm going to call this A, like angle. All right. So that's what I get. That's a decimal form. Okay. What I'm going to do now is I'm going to multiply A, my answer, by that original denominator. So 7A, and notice I get 8. And what I have here is 7A is equal to 8. So solve for A. A is 8 sevenths. And then remember, what did we say we were going to do to this value A? We're going to stick the pi back on. Right? So A is equal to 8 sevenths. Right? We're going to stick the pi back on, so that's 8 pi over 7. It's the same thing that we would get if we would have done it mathematically. So let me just to make sure that we got the procedure down, let's do a similar problem here and show that it works no matter what we start with. All right, 13 pi over 4. What's that coterminal with? So same thing as before. Let's just go through the procedure. Start off with what we're given, 13 pi. All right, minus 2 pi. All right, remember, we leave off the pi. You don't have to put the pi in there and take it away. We leave off the pi. We call that A. All right, so I'm just taking that pi away. Multiply that by the original denominator. The original denominator is 4. So 5 over 4. This is the numerator. You stick a pi with it, and you put it over that original denominator. So 5 pi over 4. All right, the only thing you got to worry about here is if your fraction reduces. 29 eighths. Let's see if this one will reduce. I don't think I'll have to reduce this one either. But 29 eighths, remember, just remove the pi. So 29 eighths. I'm subtracting subtracting 2 pi. I'm ignoring the pi. My original denominator was 8, so I need to multiply this by 8. And I get 13. So 13 pi over 8. So that's all that you'd have to do if you wanted technology to help you. Things to be mindful of here if you're going to do something like that. What if my original number was something like 63 pi over 4? If I did something like this and started off with the 63 over 4, notice A is not smaller than 2. Like all these other examples that I've given you, A was always between 0 and 2, meaning 0 and 2 pi, less than 2 pi, because remember A A was the stuff that's in front of pi. We were ignoring pi. So this was, 1 point something pi. It's less than 2 pi. This example, I'm not less than 2 pi. Like 63 pi over 4 minus 2. That's not less than 2 pi. So what does that mean? Well, that means that with this one, I went around the circle multiple times, not just once or twice or 3 times. I went around over and over and over again. So 63 pi over 4 is much bigger than 2 pi. All right, you can calculate it. You can take the minus 2 away just to see. That's 15 pi. That's like going around the circle 7.5 times. All right, so we've gone way more than 2. So when I subtract 2, I'm not between 0 and 2. So what do? Well, I subtract 2 again. We just keep going around until I do get something between 0 and 2. And there it is. So this went around the circle 1, 2, 3, 4, 5, 6, 7, and part of another time. All right, so the denominator was 4. I need to multiply by not 8, but 4. So this is equivalent to 7 pi, or coterminal. Okay, so that's something you got to look out for. Another thing to look out for is if your original denominator, let's say that this was 9, and let's say that this is 15. No, let's not do, I'm sorry, let's do 30. Alright, so 30 pi over 9 was my original one. Alright, if I subtract 2, that's enough. I multiply by 9, I want you to see what I get here. I get 12. So 30 pi over 9 is coterminal with 12 pi over 9. But 12 pi over 9 reduces. There's a common 3 here. That's 4 pi over 3. We want to always reduce. So if you do this work and you get something out that has common factors in the top and bottom, you need to reduce it, or you won't get credit. So this example, all the ones that are similar to this one in your homework, you only have to subtract 2 pi once. But sometimes you have to subtract 2 pi multiple times to get something that's coterminal. Right? And sometimes you have to reduce after you found something coterminal. So just be careful with those. But most of the ones that you're going to see that are similar to this problem in your homework set are just going to involve a single subtraction and and probably no simplification. But just know that you could. It's an algorithm, so it could pull out a scenario where there is a common factor. So always reduce, and then if you need to subtract, after you've subtracted 2 pi once, if you're still bigger than 2 pi, you need to subtract 2 pi again.